Another type of linear system application we see might be a two-value problem. For example, we might see a question like this. I would recognize this as a two-value problem because what it does is it gives two values and two situations. Right? We see that she's rented a car twice. Okay, that means we have two situations, and the values, or the cost of the car, depends on two different values: rental time and kilometers traveled. So often, if I'm not sure where to start, especially with, well, I always start with my variables. If I'm not sure what to make my variables, looking for what the question is actually asking me is a good place. So I'm going to let T be the cost per day, and I'm going to let D be the cost per kilometers. T for time and D for distance. I like to have variables that match up to what I'm looking at. So looking at the situation, I have 3 days, 150 kilometers being 800 bucks, or 180 bucks. So I would say that that's 3T and 150D equals 180 bucks. I also have 400 kilometers for 2 days, also equaling 180 bucks. So 2T and 400D equals the same 180 bucks. Now I realize that the question wasn't written very well, that this part here, that the second situation also cost $180, wasn't very well communicated in the question, but take my word for it. It should have said that the second time it also cost 180 bucks. Well, we can attack this thing then. We'll call this equation 1 and equation 2. And we can solve probably the best way by elimination. What do we want to eliminate? The t's or d's? Looks like the t's are simpler, so I will take the top one, multiply it by 2. Take the bottom one, multiply it by 3. And here we go. 6t plus 300. D equals 360. The second equation multiplied by 3 gives me 6t plus 1200d, and 180 times 3 is 540. I am going to, of course, want to document that I am adding equation 1 to equation 2. No, that wouldn't work. I am going to actually subtract equation 2 from equation 1. That will eliminate my t's, and that will give me a negative number here. I think negative 900d will equal 360 minus 540, which is, I think, negative 180. Divide both sides by negative 900. That works out to 18 over 90, which I guess is 2 over 10, which I guess in the end is 1 over 5. So D equals 1 over 5. So I guess the D, the cost per kilometer, is 1/5 of a dollar per kilometer. Since we're talking about dollars, I guess it would make more sense to say that D is 0.20 or 20 cents. So we will then just use that to find out what the cost per day is to solve for T. So we will sub D equals 0.20 into, we choose 1 or 2, let's just choose 1. Here we go, 3T plus 150, 0.20 equals 180. 3T plus, I guess that's 30 equals 180. 3T equals 150. T must equal 50. Alright, so it looks like I have a number for T, my cost per day. I have a number for D, my cost per kilometer. And I will conclude that, therefore, it costs 20 cents per day, or no, 20 cents per kilometer, and $50 per day to rent the car. finally, I just wanted to demonstrate how to get started on a specific value/total type of problem. In these types of problems, you will see two different substances being combined, and you have two supplies of them. One is a supply that has a bit of a higher concentration, and one has a supply of a bit of a lower concentration, and the concentration is given by what percent of it is pure. And it always gives you how much you want to make altogether. It gives you the percent composition that you want of your final product. So it's really just a value and number, or value and amount type of problem. So in this case, your amount will be how much you actually want to make. And the amount we want to make is 250 milliliters. So what's going into our 250 milliliters? Well, some of the 5% acetic acid and some of the 10% acetic acid. And so we should define some variables. We should let's see, 5%, let's use F for 5%. Let F be the amount in milliliters of 5% acid, and let T for 10 be the amount in milliliters of 10% acid. Okay, so some of the acetic acid, the 5% acid, the F, and some of the 10%, the T, will go into my final amount. Right? So that leaves us needing a value equation. And this is a little tricky to understand, but it involves with knowing that if you have 5% acetic acid, let's say I had 100 milliliters of 5% acetic acid. Well, 5% of that 100 milliliters is 5 milliliters. And that means that out of that 100 milliliters of 5% acetic acid, there is 5 milliliters of pure acid. Right? So I actually want to know, in whatever amount of 5% acetic acid that I use, how much of that is pure acid. Now I can always find out how much is pure acid by multiplying how much of it I have, the F, by the percentage that is pure. Right? So I'm going to take 0.05, right, percent as a decimal, multiply by F. I'm going to take the amount of 10% I have, that's my T. I'm going to multiply that by what percent of that is pure. And I'm going to say that the amount of pure acid that I have in my final mix is going to be the amount of final mix that I have times the percentage that is pure. So my two equations are that F plus T equals 250, and that 0.05 F plus 0.10 T equals 20, because that's what 0.08 times 250 is. Now, I'm all about substituting when I can, so I'm just going to say F equals 250 minus T, and I'm going to sub 1 into 2, and away I go. 0.05 times 250 minus T equals, nope, not equals yet, plus 0.10 T equals 20. 0.05 times 250 is 12.5. So 12.5 minus 0.05 T plus 0.10 T equals 20. I'm going to combine my T's to get 0.05 T, move 12.5 to the other side, and leave 7.5 over here. Divide both sides by 0.05, and I get that T equals 150. Okay, it's an easy finish to this. I'm going to sub T equals 150 into 1 F plus 150 equals 250. F must be then 100. Therefore, I need 100 milliliters of 5% acid, and what did I say? 150 milliliters of 10% acid.